Hello guys, welcome to this new video. In this video we are going to solve a problem of Iran Physics Olympiad level 3, and the problem is about some blocks that we attach them to some ropes, and then we have some pulleys here, which the first pulley is attached to the wall, that it's motionless, the wall is stable, and also it's a good problem for dynamics. Let's read the problem. Actually, it says that according to the picture, we attached n plus 1 blocks with mass m to n pulleys. Here we have n plus, here is block 1, first block, here is second block, nth block, and n plus 1th block. We have n plus 1 block with mass equal masses m to n pulleys. The pulleys are massless and we don't have friction, and also the ropes are massless too. I forgot to write actually here in the problem. Suppose the gravity acceleration is g and the tension in the uppermost rope, I mean in this rope, is actually m beta. Take the positive direction downward. Also the acceleration of the kth block is ak and the acceleration of the kth pulley is bk. Okay. Part A of the question wants us to find actually the tension in the kth rope. What is the kth rope? It is the rope which is attached to the kth block in terms of beta. Okay, first we want to actually solve part A and then go to next parts because it has a lot of parts question, and if we want to write them, I think it's wasting time. We actually go without wasting time, go to part A. Okay, let me to write here solve. Okay, and what should we do to actually find the tension in the kth rope? Look at here. Let me to copy this picture. Sorry. This is the picture of the question. And this is the first rope. Actually, it is the first rope. This is the first rope. It is green. I colored it with green. This is the first rope. Let me to find actually the tension in the first rope. Then maybe I can actually generalize that and find the tension in the other ropes. Okay, what is the tension in this rope, you think? Actually, because the rope is massless, the first note is that the actually tension in the rope is actually a constant. And for example, if let me to write something here. For example, consider that this is a rope. This is the rope, and we have the force F in F1 in this side, and also F2 in this side. What's the relation between F1 and F2? And also we know that the m is 0 of this rope. And also we know that the acceleration of the rope is not infinite. Actually, it's a finite value. Okay, according to Newton's law, which we have sigma of F is equal to m times a, and because the m is 0 and a is not infinite, because maybe 0 times infinite, maybe it is going to be a constant, but here a is not infinite, so it's going to be 0. So sigma of f is going to be 0. So f1 minus, for example, if we take the positive direction to the right, f2 minus f1 is going to be 0. So f2 is going to be equal to f1. So the tension in the rope actually is constant, and for example it's equal to F, something like F. If we have a tension, for example, in here, if we have a tension here equals to which it is equal to actually T1, the tension in the rope 1, which is attached to the block 1. Here again, also the tension is T1, according to the proof here. So it's a kind of proof. And also the tension here is which it affects the first pulley, which it is motionless, is T1 again, and also it is T1 because the tension I set in the rope is constant. So and also the tension in here, we understood the actually the problem suppose that the tension in the uppermost rope is T equals to m beta, and also this is T2, sorry about the line, and also it is Tn. Okay, this is T2, and also this is T2. Okay, how can we obtain that? What is T1 and T2, Tn? How can we obtain that? And we can write actually Newton's law for the pulleys. For example, let me to write equations for the first pulley. I consider that it is the first pulley. Here we have T equals to m beta, and here I have T1, and here again I have T1. Again, because the acceleration is not infinite, it is actually finite value, and the mass of the pulley is equal to 0. So we can write something like this: 2T1 is equal to T, which is equal to m beta. And also we can generalize it for the kth actually pulley. For the kth pulley, what should we write? We can write that here for the kth pulley. Here we have T K, again here we have T K, and Tk minus 1 upward. So 2Tk is equal to Tk minus 1, and also 2T, for example, 2 is T1, and so on. So here we can obtain that T1 is m beta divided by 2, and if we substitute this to the second equation, we can obtain that T2 is equal to m beta divided by 2 to power 2, and if we go like that, we obtain that T of k is going to be m beta divided by 2 to power k. So we found the actually tension in the kth rope. So the Tk is going to be m beta divided by 2 to power k. It's the part A of the problem. Okay, let's go to the second part of the problem. It wants us to find the acceleration of the kth block in terms of g and beta. For this part, it is obvious that we should actually write the Newton's equation for the kth block. Okay, so let me to write the equation. Here we have the kth block. Here it is the kth block. It is the kth block. Is kth block, and we have an actually we have a tension. We have a tension here, which it is kth rope, which tk, which the tension in it is tk, which it is m beta divided by 2 to power k. And also we have a gravity force, which it is downward. It is downward, and it is equal to m times g. And consider that the question says that consider that the kth block is a k. So, and also the positive direction is downward. The positive direction is downward. So I consider that the acceleration of the kth block is a, downward. So I can write m a is equal to m times g, which is, it is positive, it is downward, minus m beta divided by 2 to power k. And from here, sorry, it is k, ak, and from here I can extract that ak is equal to, we can eliminate m from both sides, g minus beta divided by 2 to power k. It's part B of the question. ak is equal to g minus beta divided by 2 to power k. It is part actually B. Okay, let's go to part actually C. It says that since the length of all ropes is constant, it means that actually during the time the length of each rope actually doesn't change. It means, for example, consider that the length of a rope is L. So the derivative of the L with respect to actually time is 0. Since the length of all ropes is constant, there are some actual limits on acceleration of blocks and pulleys. Write these conditions, means find some relation between AK, BK, and BK plus 1. Let me to draw a picture to show actually the kth block, which has acceleration AK, and the pulley B, and the kth pulley, which has the BK acceleration, and also the K plus 1 pulley, which has BK plus 1 acceleration, to actually try to find some relation between them. So here we have actually the kth pulley, which it is attached to the kth block, which again it is attached to the let me write a better picture. Which it is attached to the it is kth pulley, it is kth block, and it is K plus 1 pulley. So how can we obtain a relation between the accelerations? Actually, and the hint is that the length of this rope, let me to color it, let me to make it green. The length of this rope actually, the length of this rope is a constant. The length of this rope that it is attached to the kth rope, and it goes over the kth pulley, and again it is attached to the K plus 1 pulley, is constant. But what is the length of this rope, you think? What is the length of this rope? What is the length of this rope? Let me to write a wall. Draw the wall here. It is the wall, and let me to say that the place of the kth block with respect to this wall, which I take it as the origin of our coordinate system, is actually x of k, and also the place of the kth rope, kth actually pulley is y of k, because it's pulley and it's block. I because of that because of the fact that it's block, I said it x, and because it is pulley, I said it y, and also it is y2. Actually, you may have a question that why did I take the wall as a origin for our coordinate system? Because actually the wall is motionless and it is stable, and it doesn't move during the time, in the duration of time it doesn't move actually. And we should have an stable coordinate system to actually write equations for that, from that origin, from that system. So I took the wall as the coordinate system as the origin. So if y, and let me to state the yk plus 1, if I want to write actually equation for this and for the length of the rope in terms of x of k, y of k, and yk plus 1, uh, let me to color it. Let me call the length of the rope L, for example. L is equal to this part of the rope, which it is x of k minus y of k plus suppose that the radius of the pulley is r, for example, plus this part of rope, which it is pi r, sorry about the pronunciation, pi r, and also this part of the rope, which it is plus yk plus 1 minus yk. If I take a derivative from this actually expression which I actually obtained here, we can understand, because the L is constant, the derivative of it with respect to time is 0, d over dt, it is 0, but because x of k and y of k and also yk plus 1 change actually, and when time goes, we have actually their derivative, and I showed them with dot actually, for example, x dot k minus y dot k, because again pi and r are constants, the derivative of this expression is going to be 0 plus y dot k plus 1 minus y dot k. Another derivative and another derivation for actually extracting the accelerations, we obtain that it is 0 is equal to x double dot of k minus y double dot of k plus y double dot k plus 1 minus y double dot k. And also you should notice that x double dot k, which it is the acceleration of the kth block, is ak. The acceleration y double dot k, which it is the acceleration of the kth block, is bk. And also the y double dot of k plus 1 is the acceleration of the k plus 1 pulley. So we obtained here that, let me to change the color, we obtained 2bk is equal to actually ak plus bk plus 1. 2 bk is equal to actually ak plus bk plus 1. Okay, this is actually part C. I think it was C. Yes, it was part C. Let's go to part actually D. It says that with the help of the above equations, find bk in term of beta. Actually, this part actually is the most difficult part of this question, and it is not so difficult, but it is actually the most difficult part of this question. What should we do actually to find this actually bk in term of beta? Actually, here we have bk, and also we obtained ak above, which was actually here. Ak was g minus beta divided by 2 to power k, and if I substitute actually this ak in this in the c equation, I can obtain a recursive actually equation for b, and for the accelerations of for the acceleration of actually pulleys. Let me to substitute this ak into this actually equation. 2bk is going to be equal to ak, which was g minus beta divided by 2 to power k plus bk plus 1. As you can see here, it is actually a recursive equation. You can see bk plus 1 is equal to 2bk minus g minus beta divided by 2 to power k. Okay, how can we actually obtain b as an f, b of k as an f which is function of k? I don't want to have actually b of k here. I want to obtain something which it is just which I can see just k in the right side of the equation. My actually opinion is that we can write, for example, the first, for example, 3 of the equations, 4 of the equations, and see that if we can obtain a relation between b and k's. It is not a bad solution. It's not a bad idea for solving this part. So I forgot to say a note. How if we have a recursive equation, we should also have, for example, the first actually for example, we should have b0, or for example we should have b1 or something like that. We have actually, if you paid attention, what is b1? It's the acceleration of the first pulley, which it is this pulley, which the acceleration of this pulley, because it is attached to the wall, is 0. So b1 is 0 actually. You should notice that b1 is 0. So from this I want to obtain b2. b2 is going to be 2 times b1, which is 0, minus g minus g minus beta minus g plus beta divided by 2 to power k. Okay, we have b2, which it is minus g plus b, sorry about this, 2 to power actually I substitute co with 1 here, so it is beta divided by 2, and for b3 we have 2 of this b2, which it is minus 2g plus beta minus g plus beta divided by 2 to power, actually I substitute k with 2, so 2 to power 2 is 4, so I write here 4, which it is actually b3 is minus 3g plus 5 beta divided by 4. So let me to erase it and write it here. Okay, next one is b4. For example, we can obtain that 2 of this 2 times of b3, which it is minus 6 times g plus 5 beta divided by 4, sorry, 2, it's multiplied by 2, plus actually minus g plus beta divided by 8. 2 to power 3 is 8, which it is actually b4 is minus 7g plus actually 21 beta divided by 8. To erase it again and move it upward. And also I think we can now understand what is the relation, but let me to write also b5. It is minus 14g plus 21 beta divided by 4 minus g, which causes this minus 14 to minus 15, plus m beta beta divided by, actually I think 2 to power 4 is 16, so it is going to be 85 beta divided by 16. Okay, as you can see here, we can obtain the relation, which bn is actually is made from actually 2 parts, minus, I call it an g, plus also for example cn multiplied by beta divided by, for example, here, for example, if n was 4, here in the denominator of the second part we had 2 to power 4 minus 1, and here we had 2 to power, for example, 3 minus 1, and so here we have, for n we have 2 to power n minus 1. But what is an and cn? Here you can see that for example from number 3 to number 4, if you actually double the an a3 and then add it by 1, you can obtain a4. For example, 2 multiplied by 3 is 6, and when you plus it by 1, it is 7. Or for example, 7 times 2 is 14, plus 1 is 15. So an plus 1 is actually 2an plus 1. And what is cn? What is cn plus 1? Cn plus 1 is actually 4 times of each, so 4 times of cn plus 1. For example, from b3 to b4, you can obtain b4 by multiplying c3, which it is 5, by 4, which we can obtain 20, and then 20 plus 1 is 21. So it is 4 times of cn plus 1. Also I suppose that you are similar to with these actually recursive equations. Actually, for example, in this equation you can actually guess that the an is something like gamma is something like an is something like gamma times 2 to power n plus some constant, for example, like phi. And here also cn is something like, again, for example, gamma prime 4 to power n plus, for example, phi prime. And here we can substitute actually these equations in these equations to actually find the constants gamma and phi. And also we know that for example, a1 is what was a1? We know that b1 is 0, so a1 actually is 0 and a1 is equal to b actually a1 is c1 and they're 0. So we know that a1 is 0 and c1 is 0 because we need two equations to find actually each gamma and phi, because we have two actually variables and that which we two unknowns and which we want to find them. So we should have actually two equations. One, the first equation, which we substitute this an to actually this equation and find a constant, and again we use this equation to find the second constant, and we do the same for the c. So if I substitute an in that equation, an plus 1 is going to be gamma 2 to power n plus 1 plus phi is going to be 2an, which it is gamma 2 to power n plus 1 plus 2 phi plus 1. And we can eliminate this from both sides, and we have phi actually equals to -1. We obtain phi equals to, actually let me to check it is correct or not, 2 times an plus 1, and also here 2 times an is going to be something like that. It's true. Okay, so phi is going to be -1, and according to this, actually according to this equation, which a1 is going to be 0, if I substitute n with 1, so I can obtain that 2 gamma plus this phi is going to be 0, so 2 gamma is going to be minus phi, which it is 1, so gamma is going to be 1 over 2. So from this I can obtain an is going to be 2 to power n minus 1 minus 1. This is a of n. And also we can obtain c, which cn plus 1 is going to be 4 times of cn plus 1, so gamma 4 power n plus 1 plus phi prime is going to be 4 times of cn. 4 times of cn is going to be it's gamma prime, and gamma prime 4 to power n plus 1 plus 4 phi prime and plus 1. Also again we can eliminate this expression from both sides, and I have 3 phi prime equals to -1, so phi prime is equal to -1 over 3. And again c1 is 0, so c1 is 0, so gamma prime 4 gamma prime plus phi prime is 0, so it is minus phi prime, which it is 1 over 3, so gamma prime is 1 divided by 12. So I can obtain that cn is going to be 1/3 of 4 to power n minus 1 minus 1 over 3. It is cn. Okay, now which with these actually an and cn, we can actually find bn, which it is this is bn. So bn is minus ang. Bn is minus ang. What was an? was minus plus beta divided by 2 to power n minus 1 times Cn, I think, times Cn. And Cn was 4 to power n minus 1 divided by 3. So we actually here we found Bn, but sorry, I think that the question wants us to find Bk. Yes, Bk. So I substitute actually n with k. It doesn't change. I can say that Bk is equal to 2 to power k minus 1 beta, actually 2 to power k minus 1 4 to power k minus 1. Actually here I obtained b of k in terms of actually k and beta and also g, which I think is the answer of the part actually D. I think this is the answer of part D. Yes. So now it wants us to actually find the tension in the uppermost rope T. What was the tension in the uppermost rope? It was actually T equals to m beta. Actually, it wants us to find exactly what beta is. And also, we should check our answer for n equals 1. But how can we obtain what is beta with actually with help of this part D? Because the problem is level by level. We should actually obtain each part from the previous parts. Actually, how can we understand what is beta? Actually, the note of this part of the question is that you should pay attention to the last system, which it is the nth pulley, which it is attached to the nth block and n plus 1th block. Here actually in fact we in the other actual systems we had a pulley which the left side is attached to the block and the right side is attached to another pulley. But here this pulley, the both left and right sides are attached to the blocks. So actually the equation for the last system actually is different from the equation for the other systems, for the previous systems. But what is this? What is the equation for this system is? What the equation for this system is? In fact, let me to actually write the picture of the last system. Here is the nth. Oh, let me change the color. Here is the nth pulley, which it is attached to a block, to the nth block, and also to the n plus 1th block. It is n plus 1th block. So we said that the tension here in both ropes are actually equal. Because in the both sides, because the rope actually is massless. So here we have a tension Pn, and here again we have tension Pn. And consider that this is the wall, which it is our actually origin. This is A of n. Sorry about the bad line. Let me to write this write like this, and also n plus 1 block. It is actually x of n, and it is xn plus 1. Actually, if I write the Newton's equation for both of these blocks, the equations are same. This is the for example, this is the block, and we have here tension Tn and a downward force which it is m times g, and the mx double dot which it is the acceleration of the nth block is m times g minus Tn, and also for the n plus 1th block is mx double dot of n plus 1 is again mg m times g, because because the mass of the blocks are equal and same, or the blocks are similar, minus T n because the tension again in the rope is constant. So from these equations we can obtain that an, which is x double dot of n, is equal to an plus 1. So for the last rope, actually the two tensions are equal, and if I want to here we had and the limit or the condition for the accelerations, and for example, if I actually let me to copy this and paste it here, we had this equation. If I substitute actually this k with n, what will I give is that 2bn is equal to an plus bn plus 1. But we don't have bn plus 1 because we just have n pulleys. So bn plus 1 is just an plus 1 because it is a block. And an plus 1, according to this equation, an plus 1 is just an. So from this we can obtain that bn is equal to an for the last actually system. So and also we have an. What is an? An is nothing, just here we obtained a of k. Here we obtained this. Let me to copy this again and paste it here. And we also had ak, so an is just g minus beta divided by 2 to power n. So now we have a of n in terms of beta, in terms of g and beta, and also I know that an is equal to bn, and also I have bn from here. From here I have actually bn because I have bk, so I have bn. What is bn? bn is just an, which it is g minus beta divided by 2 to power n, which it is equal to the right side of this equation, but it has a different k, which it is n. Let me to write it. I think I should write it. No, I can copy this and paste it here, and just actually substitute k with n, the number of actually pulleys, to n minus 1, 4 times n minus 1. Actually from this equation we can obtain actually we can find beta in terms of g and n, and after that we can substitute it into t equals m beta and find t in terms of g and m, and also n, the number of pulleys, or in the other words the number of actually the number of pulleys, the number of blocks minus 1. But let me to solve this for beta. If I move this expression here, we can obtain that g actually 2 to power n minus 1 is equal to beta divided by 2 to power n minus 1, 1 over 2, plus 4 to power n minus 1 divided by 3. Let me check if it is true or not. Okay, it is. I think it is true. I factor here beta divided by 2 to the power n minus 1. It is 1 over 2. I think it is true. So if I want to find actually beta, let me to actually make a common denominator here. Beta divided by 2 to the power n minus 1, which it is 2 times 3 is 6, and here we have 3 plus 2 times 4 to the power n minus 1 minus 2, which I can make this 1. So g is just, beta is just g 4 to the power n minus 1 6g divided by 1 plus 2 times 4 to the power n minus 1. It is beta. Let me to check if it is true or not. 6g actually 4 to the power n minus 1 divided by 64 to the power n minus 1 divided by 1 plus 2 times 4. Yes, it is true, I think. So from this we can obtain t, which it is m beta is equal to 6 mg 4 to the power n minus 1 divided by 1 plus 2 to power times 4 to the power n minus 1. So this is actually T, the tension in the uppermost, actually the tension in the uppermost rope. It is part, what was this part? It was part E. Okay, the question says we should check our answer for n equals 1. What is T1? It is Tn. No, sorry, Tn is not Tn, it is tension in the uppermost. T4, for example, n equals 1. Let me to write like Tn equals 1. It is 6 m times g, 4 to the power 1 minus 1, 4 to the power 0 is 1. And here we have 1 plus 2, which it is 3, and we can do something like this. It is 2m times g. What should we expect to have for n equals 1? N equals 1, it means that we have just one pulley. It means that the problem is just a wall and a rope, which it is attached to both walls and sorry about the bad picture, wall and also the only pulley. And here we have a block, and here again we have another block with both masses m and m. Because the masses are the same, so actually we can guess that our system is actually in a stable and it is in the equilibrium mode, and it is motionless. And what is the tension here? It is, for example, suppose that this tension is actually a T prime, and also because the rope is massless, the tension here is also T prime, and we have T n equals 1 here, and because we don't have any movement, so T prime is equals to mg, for example, for the actually Newton's law for this part. And also, so if I want to write the equation for the pulley, we have a T n equals 1 here, and just 2 t prime here and another t prime here. So Tn equals 1 is because because we don't have any movement for actually the only pulley. Tn equals 1 is equal to 2t prime, which it is 2m times g, which actually it is compatible to the result which we extracted above. So I think our answer is true to this part. So let's go to the next part. What is the acceleration of the kth block? The acceleration of the kth, what was the acceleration of the kth block? The acceleration of the kth block was just actually ak equals to g minus beta divided by 2 to power k. And also we found beta, and what was beta here? This was beta. Let me to copy this. This was beta, so I paste it here. And if we substitute this beta in the this actually equation, we can find that ak is equal to g minus 1 to power 2 to power k, 6g 4 to power n minus 1, 1 plus 2 times 4 to power n minus 1. Because here we have n and here we don't have anything, is constant. I think we can't simplify this more. So actually this is part, we can say that this is part f. I think this was f. Yes, this is part f. This is part f. And the last part of the question is that in the limits of n to infinite, find the acceleration of the first block and the tension of the uppermost rope. Okay, we should find the acceleration of the first block. First, let us to find the tension of the uppermost rope in the limits of, because we here we have tension with the function of n, so we can have the limits when n goes to infinite. Let me to copy this. 4 over n minus 1. Okay. Here, what is this? Copy all of it. Okay, this is t, and erase it. Let me to find the limit of t when n goes to infinite. It is 6. It is the limit of 6m times g. Let's to divide both numerator and denominator by actually 4 to power n minus 1. It is 1. If we do this, it is 1 over 1 to power n minus 1 plus actually 2, and n goes to infinite. This expression, this term is going to be 0 in that limit, so we will have just 3mg. And also it says us to find actually the acceleration of the first block. We have the acceleration expression here of the kth block. So if we substitute a with k with 1, we have a1 here, part g, I think it's g1, for example. Let me call this g1. This is g1, and acceleration for the first block is a1 is g minus 1 over 2 6g 4 to power let me write it here, 6g. Let me to divide again both numerator and denominator by 1 to power 4 n minus 1. If I want to actually calculate a1 when n goes to infinite, again this term is going to be 0, so we just have 1 minus 1 over 2 6g, and again 1 over 2, which it is actually g minus 3g divided by 2, which it is minus g divided by 2, which it is again compatible to what we thought about this acceleration, while our actually tension is something like this, because for example consider that it is the first pulley, and here we have a tension 3mg, and we also noticed that we also found out that the tension here is the half of the tension here. It is 3 mg divided by 2, because I don't say the reason, because we obtained that, we explained that above. And here we have m times g, and it is a of a1. So m a1 is equal to m times g minus 3 m times g divided by 2, which actually we can obtain here that a1 is minus g over 2, which it is compatible to this result. Okay, and actually we finished this problem. It was a good problem. We wrote a lot here. Actually, it was a dynamic problem. I hope you enjoyed this problem, and if you want us to actually record more videos about physics problems, for example in cinematics or dynamics, electromagnetism, thermodynamics, or something like that, mathematics, or something else, or if you enjoyed this video, please subscribe our channel, and just that. Thank you.